Estimation is often done by sampling, which is counting a small number of examples something, and projecting that number onto a larger population. An example of estimation would be determining how many candies of a given size are in a glass jar. Because the distribution of candies inside the jar may vary, the observer can count the number of candies visible through the glass. Consider the size of the jar and presume that a similar distribution can be found in the parts that cannot be seen, thereby making an estimate of the total number of candies that could be in the jar if that presumption were true. Estimates can similarly be generated by projecting results from polls or surveys onto the entire population. Estimation of width, by Napoleon method. Stand on one shore of a stream. Bow your head, chin against your chest. Hold your hand to your forehead in a salute. Move your hand down until the front edge of it seems to touch the opposite shore. Without changing the position of your hand, make a quarter turn. Notice the point at which the edge of your hand seems to touch the near shore. Pace off the distance to that point, and you will know the width of the river. The next picture will explain you in detail. Estimation of width, stride or step method. Select an object on the opposite side of the river, such as a tree, and we mark it as A. Mark the point directly in front of the object on the opposite side of the river. Mark it as point B. Take at least 50 paces to point C, so as to form line BC. Note that line BC should be perpendicular to line AB. Mark point C with a stick or another person. Again, pace another distance to point D. The distance CD is half the distance of BC. From point D, pace another distance to point E. Line DE is parallel to line AB. Point E is marked on a location wherein you can see point C forming a straight line with point A, meaning when you look at the stick on point C, it somewhat blocks your line of sight to point A. The distance AB is twice the distance DE. AB equals DE times 2. We can alter the method a bit. Instead of having distance CD half the distance between BC, we can make it equal to each other. The next picture will explain you in detail. Estimation of height. Estimation of height is a useful skill for scouts and guides. Each one of the below methods needs to result in a height measurement in meters, and the input into some of these methods needs to be distances and heights in meters or centimeters. Scouts are hardly likely to carry around a ruler or tape measure, so each scout should know some of the physical dimensions of their own body to attain this, such as the width of the thumb in millimeter, the span of the outstretched hand in cm, the length of the forearm in cm, the length of one pace in centimeter, one's height in m. The knowledge of these measurements above is an important prerequisite to most these height estimation methods below. Without them, accurate height determination is not easily attainable. Estimation of height, by Lumberman's method. Take a pencil or short stick in your hand and hold out in front of you, so that the tip of the pencil is level with the tip of the object you are measuring. Next you need to line your thumb up with the base of the object. Once you are sure the tip of the pencil and your thumb are in the right place, turn the pencil so it is horizontal, but with your thumb still on the base of the object. Now you will need a friend to walk from the base of the tree at 90? A right angle from you until he apparently reaches the tip of the pencil. You then need to mark this point and measure from it to the base of the object, and this should give you a reasonably accurate height. The next picture will explain you in detail. Estimation of height, by 1 in 10 method. This is a great method of height estimation when the ground is level, and the object for which you need to determine the height is fairly upright and perpendicular to the ground. From the object, measure a distance of 9 units along the ground. The units can be anything: paces, stave lengths, meters, or even the height of one of your scouts. Place an upright stave in the ground at the 9-unit distance. Mark a point in the ground, 1 further unit back, using the same unit that you used to measure the 9 units from the object. At the point that you have just marked on the ground, place your eye as close as possible to the ground and look up at the top of the object. Ask a fellow scout to put a finger on the stave, and move it up or down on the stave until your eye, the finger, and the top of the object are in line. Once they are in line, measure the distance to the ground from the scout's finger, height A in the diagram above. The height of the object is 10 times what you have measured in height A. The next picture will explain you in detail. Estimation of height, by shadow method. This method is best used when the sun is low in the sky and casting fairly long shadows. Needless to say, it cannot be used around noon. Measure the height of the stave, call it SH. Measure the length of the stave's shadow, call it SS. Measure the length of the object, tree, shadow, call it OS. The height of the tree then is OS divided by SS multiplied by SH. The next picture will explain you in detail. Estimation of height, by stick method. This method is most probably the easiest and quickest method, but also the least accurate. Look for a straight stick the same length as your straightened arm. Hold the stick up in a perpendicular position at the end of your extended arm. While holding this pose, step backwards away from the object whose height needs to be determined until the top of the stick, and the top of the object are in line. The height of the object is then determined by your distance from the tree. The next picture will explain you in detail. Estimation of height, by felling method. This method is a quick and fairly accurate method of determining the height of an object. Best used when the object of which height you need to determine is some distance away. Holding a stick upright on an extended arm, align your eye, the bottom of the stick, and the bottom of the object, as well as your eye, the top stick, and the top of the object. You may need to adjust the length of the stick and your distance to the object to accomplish this. Once you have done this, turn your arm through 90 degrees, maintaining the alignment between your eye, the bottom of the stick, and the bottom of the object. Then ask one of your scout colleagues to stand at a right angle relative to your position with the object, and distance him or herself from the tree, such that there is alignment between your eye, the top of the now horizontal stick, and his or her position. The distance between the scout and the object is now equal to the height of the object. The next picture will explain you in detail. Estimation of height, by 10 method. This method will give you the relative height from your current altitude, and is useful for more distant and very high objects. To use this method you need to know the horizontal or map distance to the object. This one can usually get from a map. For example, on a 1 is to 50,000 map, 2 centimeters on the map equals 1 horizontal kilometer on the ground. This method requires the use of a calculator or a mobile phone, the latter of which most scouts nowadays carry. Estimation of height, by proportional stick method. This method is a quick and fairly accurate method of determining the height of an object, but using proportional measurements of an object of known height. Place a scout of a known height near the object of which you need to determine the height. With a small stick in hand and your arm steady, walk some distance backwards from the scout, until the top of the stick is in line with the top of the scout's head, and the bottom of the stick, where you are holding it, is in line with the feet of the scout. At this point, stop moving backwards. Take note of the distance from your hand to the top of the stick, and let's call that distance x. Keeping your arm steady, move the stick up incrementally by x, until the top of the stick is in line with the top of the object of unknown height. Count the number of times you have to move the stick up. The height of the object, the tree in the case of the diagram, is the height of the scout multiplied by the number of times you had to move the stick up. The next picture will explain you in detail. Estimation of depth, by rope method. Use a rope or a twine with some heavy object tied to it. Let it reach the bottom. Measure the rope, it is the depth. For measuring the depth of an open well, if you see the equal layers of bricks or masonry work, count the layers and multiply by the height of each layer. The next picture will explain you in detail. Estimation of weight. Estimation of weight of things is skillful for scouts and guides. To measure approximate weight from smaller to bigger weights up to 100 grams, 500 grams, and so on. There is a suggested method. Take a stick to a rod of equal thickness throughout its length. Then know the weight of one object like your knife, torch, cap, and so on. Now hang that object to the one end of the rod. Similarly, hang the object to be weighed to the other end. Now lift the stick from some point so that the stick is equally balanced. Then measure the distances from the point to both ends. Use the following formula to measure. W1 multiplied by D1 equals W2 multiplied by D2. Or W2 equals W1 multiplied by D1. The next picture will explain you in detail. Estimation of number. Estimation of number is the most effective way of estimating a crowd, marbles, flock of sheep and so on. There is a method to get the approximate number of things. Count a group of say 10 or 20 people or things on the crowd. Work out as the best, how many groups of that number are in the crowd. Multiply it out and you have an estimate of the total number in the crowd.